All right, I'm making a screencast-o-matic video right now. We'll see how this goes. I've never made one before for class. I want to try my best in less than 5 minutes to quickly address the errors I saw in the exit card on section 4.1. I did give everyone 100% who did this, but I want you to know for the test where I will dock you. It says for each of the following situations, identify the sampling method used and then explain how the sampling method could lead to bias. Now I want to be really clear. Let me just switch my, whenever I am looking for bias, I want to remind you, again, sorry, forgive me, okay. Whenever you're addressing bias, anytime, whether it says it or not, you are expected to address the direction. Wow, wonderful spelling here. Of the bias. What does that mean? That means, is it higher than what you think the truth is, like the actual truth, or lower, and why? Okay, so let's talk about this one. A farmer brings a juice company several crates of oranges each week. A company inspector looks at 10 oranges from the top. Okay, now the 10 oranges from the top of each crate before deciding whether or not to buy all the oranges. This is actually a convenience sample, okay? He didn't put all the oranges in a hat and pull out which ones to look at. He just looked at the top. It was most convenient for him. Now, when you're addressing the bias, I'm not going to type it because that just takes more time and I don't want to spend too long on this video. You'd say that's a convenience sample. This led to bias. The oranges on top are probably better quality, okay, than the whole crate of oranges. The ones on the bottom might be better. You would need a random sample in order to really pick and see how the overall crate of oranges, what the quality is there. So again, just to repeat, the better ones are probably on top. They're not smooshed down. It's like that whole crock pot of chili just skimming the surface. It tastes spicy. This case, it's the reverse, right? They're gonna be the good oranges on top. Okay, you really would want to like almost number the oranges and pull out numbers, and those are the oranges you want to look at. Now, is that feasible? No, but that is where the bias comes in. So the direction of the bias is the oranges are probably better quality than that's really being reflected in the population, okay, of that entire crate. Hopefully that makes sense. Let me know if you have questions. You should have addressed all of that. I saw a lot of direction of the bias missing in this. Number 2, the ABC program Nightline once asked whether the United Nations should continue to have its headquarters in the United States. Viewers were invited, and it should say invited, to call one telephone number to respond yes and another for no. There was a charge for calling either number. More than 186,000 callers responded and 67% no. This is voluntary response sampling. Only those who feel particularly strongly about the issue are likely to respond. In this case, those who are happy the United Nations has its headquarters in the United States already have what they want, and so they're less likely to worry about responding to the question. Okay, again, did we discuss bias there? Okay, yes, we discussed bias. Did we talk about the direction of the bias? I didn't specifically say it when I was reading that result to you or reading the answer to you, but more than 186,000 callers responded no, okay? So that's probably higher than what the actual truth is. And you could go on again to say what I said. People who are happy are probably not calling because they have less likely to worry about responding to the question, right? Hopefully this made sense to you. To sum it all up in the last 40 seconds that I have, when you are addressing bias, you're going to say the sampling technique that led to bias, so convenience sampling or voluntary response sampling. Then you're going to talk about the direction of the bias, okay? The direction of the bias. Let me give you an example that comes right from the book, and I'm probably going to go over. Suppose you were asked to explain how using a convenience sample of students in your statistics class to estimate the proportion of all high school students who own a graphing calculator could result in bias. You might respond, this sample would probably include a higher proportion of students with graphing calculators than in the population at large. Because, okay, so why? A graphing calculator is required for statistics class. That is, this method would probably lead to an overestimate of the truth, the actual population proportion of students who own a graphing calculator. Please let me know if you have any questions and make sure that you understand that concept. It is on page 210 in your book talking about bias if you need more to read about it. Thank you.